AIME 2023, we want to solve all 15 problems, maybe in some videos, and at the end I will release one video that contains all problems and solutions. We want to solve with logical solution, okay? The solutions that come to our mind, because it's important. We want to learn how to solve these problems in the exam. So the most important thing is to only solve the problems with techniques, strategies that are useful also for our exams. Okay, let's start problem number 1. It says 5 men and 9 women stand equally spaced around a circle in random order. So we have, let's write first M1, M2, M3, M4, M5, 5 men and 9 women. W1, W2, W3, W4, W5, W6, W7, W8, W9. The probability that every man stands diametrically opposite a woman is m over n, where m and n are relatively prime positive integers. Find m plus n. Because the problem says around a circle, so maybe you say, okay, if the circle rotates and they reach each other, you consider the same. But because here it's probability, it has no effect. You consider if the two cases can be reached to each other by rotation, they are same or not. And I will solve with both ways. You will see the answer is same. So in first case solution number 1, suppose that if two cases reach each other by rotation, they are not same. In this way, it is easier to solve, but maybe the problem was not probability, and you should know how to solve when two cases that reach each other by rotation are same. You should know how to solve that. So let's start. At first, we draw a circle, and one important point that is so much useful is that when you have something, for example, M1, M2, M3, M4, M5, consider the most limited case. Start from this. It is so much useful. So, look, all men should be opposite to a woman. Each man should be opposite to a woman. But if you consider, for example, W1, maybe she is opposite to a man or not. So we can understand that men are more limited than women. So let's start. For example, we have positions. It's first position. It's second position. Now let's see, one is opposite to what? For example, if you have 4 elements, 1, 2, 3, 4. If you have 6 elements, 1, 2, 3, 4, 5, 6. So for here, you can say 4 over 2 plus 1, 1 and 3. Or 6 over 2 plus 1, which is 3 plus 1, 4. And because we have 14, you can say 14 over 2, 9 plus 5. 14 plus 5, 8. So 1 is opposite to 8. 2 is opposite to 9. 3, 4, 5, 6, 7. Okay, 6, 5, 4, 3. And then 9, you say 10. Look, let's consider some of them. For example, 1 is opposite to 8, 2, 3. 3 is opposite to 10. 4 is opposite to 11. 5 is opposite to 12. 6 opposite to 13. And 7 opposite to 14. Now, we can say, okay, 5 is opposite to 12. And 7 opposite to 14, all these cases. Now, let's fill with M1 first. If we consider M1, We want to see M1 because it's more limited than WI. We start from this. M1 has how many cases to place? It has 14 times. Without loss of generality, let me tell you something before that. It says M over N probability. N is all cases. M is the number of arrangements the problem wants. So N is so much easy for calculate. You say 14 factorial because we have 14 places. Place number 1 has 14 cases to select between M1 to M5 and W to W9 and so on. 13. You say 14 cases, 13 cases, all arrangements. Now we want to calculate the numerator M, which is number of arrangements that satisfy the equation. The condition means for opposite to each Mi, we have Wi. So M1, 14, then, because of M1, without loss of generality, suppose M1 is in 1. Now we consider this place. We should select a woman here. So for this place, how many cases do you have? 9. Without loss of generality, consider your place W1. Then the woman, we can say the woman is opposite to this man. Now, in next case, you should select M2. Okay, so I think it's better to say M1 and the woman opposite to him. M2. Man number 2 has how many places? 12 places if you count, because we had 14 places, 2 of them were removed. So M2 is 12. For example, without loss of generality, suppose you place M2 here. Then opposite to 2 is 9. So in 9, you should place a woman, which has 8 cases. So without loss of generality, you place W2 here. Then again, M3. How many places are left? 14 minus 4, 10. For M3, and opposite to M3 is a woman. So you should select how many women are left. 9 minus 2, 7. So you multiply by 7. It's W3 times M4. You say, for example, if we want to place M4, how many places are left? If we count 8 places for M4 times the woman, how many women are left? How many women are left? 7 minus 1, 6. M4, so you place M4, W4. Now the last man, how many places are left? 6. So you say 6 for M5, and opposite to that man, how many places, how many women are left? 6 minus 1, W, for example, 5 you place. So there are 5 women that are left. So now we place all men. How many women are left? 4. We don't have any condition about them, so you can say 4 factorial for all women that are left. It is Mn. Now the problem says calculate M over N. So if you calculate M over N, it is 14 times 9 times 12 times 8 times 10 times 7 times 8 times 6. We are writing this times 6 times 5 times 4 factorial. We write 4, 3, 2, 1. Okay. Now we divide this by 14 factorial, which is 14 times 13 times 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, so now it's the time to simplify. We simplify 1 to 4. We simplify 1 to 4. Also 5, 5, 6, 6, 7, 7, 8, 8, 10, 10, 12, 12, 14, 14. Now the rest, if we consider 9 we have here. So for 9, we have also 9 here, 9 here, 11, 13. Okay, in numerator we have 8 and 6, denominator 11 and 13, so we can't simplify anymore. 8 times 16, 48, 8 times 6, 11 times 13, you can say 11 times 13 is 13, 13, 1, 4, 3. So we found it is this, but the problem wants what? The problem says calculate m plus n after simplify as much as you can. So m plus n is 48 plus 143. Now let's calculate this. 48 plus 143, 3 plus 8, 11. We have 1448 plus 1, 9, and 1. So the answer is 191. Okay, if we had question about, it was solution number 1 without considering that two cases reach each other by rotation. Let me tell you also if we had rotation. Before telling you solution number 2, it is if two cases reach each other by rotation, then they are same. You need this problem because maybe they don't say probability, they say calculate only numerator, the number of good cases, and if two cases reach each other, you should consider them same. Before solving this, I want to tell you two approach for calculating circular permutations that reach each other by rotation. So if we consider for three elements, I solve this with two ways, and then you will understand what should we do. Look, for example, suppose if we consider all arrangements, 1, 2, 3. You say 1, 2, 3, 1, 2, 3, 1, 2, 3. And also 1, 3, 2, 1, 3, 2, and 1, 3, 2. So this case is A. They reach each other by permutation, but you can't reach from A to B. So the answer is 2 for three cases. One approach number 1 for solving this is what? You say that you have 3 factorial, but you can rotate each case 3 times 3, it's 2 factorial. And for general, you say n factorial over n minus 1 factorial, and it's correct. But approach 2, always useful, man. Here, with both approaches, you can solve, but in many problems, only approach number 2 works. It is what? You say, okay, why these things reach to each other? The reason is because when you rotate, you will see, for example, 1 goes to 1, then 3 goes to 3, all these things. So, if you consider 1 fixed 1, rotate all cases to have 1 on top. Then you say, okay, other elements has how many cases? Other places, 2 cases, 1 cases. So, you fix 1 by 1 case, then the other cases 2, other elements 2 factorial. Or for general n, you fix 1 and other elements, you fix 1 with 1 case and other elements n minus 1 factorial. This fixing is so much useful. And in many problems, for example, when you have 3D, only approach number 2 works. Approach number 1 will be so much difficult. And here, let me explain. You say, I consider this case and this case. If you rotate any of them, the place of 1 will be bad. If we want to reach from, for example, this to this, if we rotate the first one, then it is not possible because in both cases, 1 is on top. So approach number 2 is so much important. Now, we want to use approach number 2. For this problem, both approaches, as I said before, are useful, but I want to use approach number 2, which is more important. So let's solve with approach number 2. Okay, in first step here, we know we should calculate probability m over n. The denominator is easy because you say like the thing I said, 13 factorial. You fix one of them and the others will be 13 factorial. We should focus on finding m. For finding m, we said we start with most limited cases. So we consider m1 and we consider m1 here without loss of generality and m1 on top. So we fix m1, then we've got rid of rotations. Then we can solve like previous case. You say, okay, opposite to m1, how many cases? You should select w. So you have 9 cases. Then you should select, for example, m2. For example, you without loss of generality w1. The rest will be same. For m2, you have how many places? 12, for example, without loss of generality, you place, for example, M2, let me here. Then opposite to M2, you should select one woman. 8 women are left, so you should select 8, for example, without loss of generality. Suppose you select W2. Then for M3, and opposite to him, you say, okay, 4 places are removed. 14 minus 4, 10. And opposite, for example, M3, you select here. And opposite to that, you should select a woman. You've selected 2 women and 7 women are left. So, for example, M3W3. Then for M4, you have 10 minus 2, 8 places. And for example, M4 here. And opposite to M4, you have W4, which 6 women are left. So you select this. For M5, 6 places are left. For M5, you select this. And how many women are left? 1, 2, 3, 4. 5 women are left. So you say 6, for example, W 5 here. Then 4 women. So you select 5. Then 4 women are left. So you say 4 places. So 4 factorial. And if you divide, let's divide m by n. So it will be 9, 12, 8, 1 by 9 times 12 times 8 times 10 times 7 times 8 times 6, 6, 5 times 4 factorial. We write it as 4, 3, 2, 1. And then we divide this case by 13 factorial, which is 13 times 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And then we simplify 12, 12, 11, do we have 11? No. 10, 10, 9, 9, 8, 8, 7, 7, 6, 6, 5, 5, 4, 4, 3, 3, 2, 2, 1, 1, and 1 is not important. 8, 6 are left in denominator, 13, 11. 8 times 6 is 48. 11 times 13 is 143. And then it is the simplest form. M plus n will be 48 plus 143. 3 plus 8, 111, 9, 1. So the answer is 191, 191. Okay, I considered both approaches, and let me tell you a homework for solving this. Similar, you should use second approach. Suppose we have a cube and the faces, you want to place 1, 2, 3, 4, 5, 6 to the faces. If 2 cases reach each other by rotation in 3D or 2D. You can rotate also in 3D space or on the plane. For 3D, they are same. How many different cubes can we create? So try to solve this, and if you wanted to know the answer is what, feel free to send message to my WhatsApp number. This problem is so much good for getting good at approach 2, considering circular permutation, but it is in 3D, so it is a little harder. If you want to divide by something, it is hard, but if you consider fixing elements for twice, then it will be so much easier. Okay, let's jump into the next problem. Problem number 2, AIME I 2023. It says positive real numbers b is not 1 and n satisfy the equations square root of log b of n equal to log b of square root of n and b times log b of n equal to log b of bn. So before solving this, let me tell you some rules about logarithm. At first, the definition that if, for example, log x of y equal to w, then you can say x to the power of w equal to y. The next thing, if you consider, for example, log x of yw multiply, it will be log x of y plus log x of w if you have product. And the next one, log x of w to the power of, for example, m. I use another variables not to have mistake with the variables we have in problem. It is m log. Let me also tell you this. For example, xr, you say m over r. Here we don't need this, but in some problems we need that, log x of y. Okay, so we have these points. There are around, I think, 3 or 4 more rules in logarithm. 2 approaches. We will work on this, the things that the problem needs. So let's start. The first part, it says square root of log b of n equal to log b of root n. Root n is what? By definition of root n, it is n to the power of 1 over 2. Now, if we use this, r is 1 here. Here we don't have any power, so m is 1 over 2, so it will be 1 over 2 log b of n. Now here, if you simplify this part, if you raise to the power of 2, log b of n equal this part, we get rid of square root. This part will be 1 over 4 of log b of n squared. Then if we do simplify, and here maybe someone says we want to simplify. Maybe log b of n is 0, or we can simplify. We divide both sides by log b of n. So 1 equal to 1 over 4 of log b of n. And log b of n equal to 4. Okay. In this case, we conclude n is 1. Okay. So we have these 2 cases. Now we should focus on second equation. Okay. On second equation, we have b times log b of n equal to log b of bn. So if let's consider first case, it is case number 1, case number 2. If we consider case number 1 that n is 1, then b log b of 1 equal to log b of b times 1, which is b. So left hand side, because log b of 1 is 0, right hand side is 1. And that's a contradiction. So case 1 is not possible. We should only analyze case number 2. Log b of n is 4. Now, if we replace in this equation, let's call this one star. By star, we can say b times log b of n equal to, here we have product. So we can use this rule. So we can say it is equal to log b of b plus log b of n. So log b of b, by the definition of logarithm, if we consider this, b to the power of what is b is 1. Log b of n is what we found here is 4. Log b of n is 4, so we say here 4b equal to 1 plus 4. Okay? Now we conclude it is 1 plus 4 is what? Is 5. So b, if we divide both sides by 4, b equal to 5 over 4. We found b. But the problem says find n. From this part, you can conclude by this definition of logarithm here. You can say this approach is useful in logarithm. One approach is say change it to power exponential function. You can say b to the power of 4 is n. So b is what? B is 5 over 4. So n equal to 5 over 4 to the power of 4. And let's see the problem once. What exactly it says? Okay. The value of n is j over k, where j and k are relatively prime, positive integers. Find j plus k. Okay. So n is 5 to the 4 over 4 to the 4. 5 to the 4 is 6 to 5. 4 to the 4 is 16. 2 to the 8 is 2, 5, 6. So it is j over k. Now, the problem, the answer is j plus k equal to 625 plus 256. 6 plus 5, 1. We have 1. 5 plus 2, 7 plus 1, 8. 2 plus 6, 8. So the answer of this problem is 8, 8, 1. We've solved the problem. Let me tell you another rule that's useful in logarithm. If we have log b of a times log a of c, then we can say log b of c. And also another thing important in logarithm problem, in other AMC and AIME problems, you should pay attention to the diagram. It will be like this. If we have x, if we have log, for example, b of x, and also we have two types. This one is for when b is greater than 1, and the other case is when b is between 0 and 1. b cannot be negative, b cannot be 1. If b is between 0 and 1, there are these, and the opposite of this is exponential function. Exponential function is inverse function of logarithm. Again, if you want to consider, for example, you want to say b to the power of x, okay? And x, if b is greater than 1, it will be this, and it is 1. And if b is between 0 and 1, it will be something like this, between 0 and 1. Okay. So we've saw it is decreasing function, increasing function, so much useful in many problems. Okay, so we've calculated this problem completely, and the answer is 881. If you had question, as I said before, or wanted to learn how to approach logarithm problems, finding the ideas of logarithm in past AIMEs and AMCs, USAMO, and all other exams, feel free to send message to my WhatsApp number in the description and comments. AIME I 2023, problem number 3. It says a plane contains 40 lines, no two of which are parallel. Suppose that there are 3 points where exactly 3 lines intersect. It means what? 3 points that 3 lines intersect, like this. Okay, so 3 points with 3 lines. It was this part, 3 points with 3 lines intersect. So before solving this, let's read. It says 4 points, so it is first 1 point, 2 point, 3 points, and then 4 points that were exactly 4 lines intersect. So the next one, 4 points, 1, 2, 3, 4, 2, 1, 2, 3, 4. So you have how many of these? 1 to 4. Then the next one. 5 points where exactly 5 lines intersect. So you say 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then it will be 1, 2, 5. Okay, and 6 points where exactly 6 lines intersect. So 1, 2, 3, 4, 5, 6. 2, 1, 2, 3, 4, 5, 6. Okay. So look, all lines are not this. I only want to write to have better understanding for this problem, and no points where more than 6 lines intersect. Find the number of points where exactly 2 lines intersect. So for 2 lines, you say, okay, first one, 2, we consider the number of them. 1, 2, for example, k. We have k points that 2 lines intersect, and the problem says find the number of them, means k is what? Now for this problem, we want to consider the pairs. Means what? When you have 40 lines, you have 40 lines. How many pairs are there? Like, for example, you consider L1 to L40. So if you consider the number of pairs, you say, okay, the number of pairs will be L1, L2, L1, L3. We don't say intersection. Why? Because maybe some lines have same intersections. Some pair of lines. Okay, so to L39, L40. So how many pairs are there? 40, choose 2. And other way, now we want to use these things. We have k of this. So, for example, it is Li, Lj. Each of these k intersection, because there are intersection of only 2, lines, you say k times each of them, create one pair, or you can say 2 choose 2. So this one we've calculated. Now let's consider this part. 3 lines, each of them 3 intersections. So for example, if you have LR, LSLT, so what are the pairs they create? LR, LT, then LR, LS, and then LSLT. The thing I'm doing in topics, they call it double counting. And it is useful in subsets, many problems. Tables, in combinatorics, it's so much useful. If you want to solve more problems, at the end of the solution of this problem, I will write some problems for double counting for homework. If you want to learn more, as I said before, feel free to send message to my WhatsApp number in the description and comments. Okay, L3 and LT. So here, each of these intersections contain 3 pairs. So plus we have 3 of that, 3 choose 2 or 3 plus for this one we have 4 intersections. In each intersection has 4 choose 2 pairs. The next one 5 times 5 choose 2, and the last one plus 6 times 6 choose 2. Okay, now we have one equation, one variable, and we want to calculate this. And by this condition, because the problem says only we have these intersections, we've calculated, and we don't have parallel lines, we've calculated all pairs exactly once. So left hand side is 40 times 39 over 2. Right hand side is k. 2 choose 2 is 1. 3 times 3. This part, the next one. 4 times 4 choose 2 is 6, because 4 times 3 over 2. Look, n choose 2 is n times n minus 1 over 2. So 5 choose 2 is 5 times 4 over 2, 10. Plus 5 times 10. And this part is plus 6 times. 6 choose 2 is 6 times 5, 30 over 2, 15. And then if you simplify, it will be 20. 0, 2 times 9, 18. We have 1. 2 times 3, 6 plus 1, 7. So we conclude 780 equal to k plus 3 times 3, 9, plus 4 times 6, 24, plus 5 times 10, 50, plus 6 times 15, 90. Now, 9 plus 50, 140. 24 plus 9, 33. So it will be what? 173. And then if we subtract 173 from both sides, 780 minus 173 equal to k. And if we calculate 10 minus 3, 7. 7 minus 7, 0. 7 minus 1, 6. Okay, so k, the answer, which is k, equal to 607. And the answer is this, but let me tell you some problems for improving your double counting. The first problem, homework number 1, is suppose A and B are subsets of, for example, 1 to 10. Then in part A, how many A and B are there such that A intersect B is null set? How many A and B are there that A union B is 1 to 10? How many A and B are there such that the number of elements, this cardinal or like absolute value, 2 vertical lines for subsets, means number of elements equal to 1. How many A and B are there? Then calculate sigma of, for all A and B, A intersect B is what? Part E. For all A and B, calculate A union B is what? So look, there are lots of problems related to double counting, but one problem that is useful is this. If you want to see the other homeworks, the other problems and improve, as I said before, feel free to send message to my WhatsApp number in the description and comments, and you can send message for checking these answers. We have 5 problems here. Okay. AIME I 2023, problem number 4. The sum of all positive integers m such that 13 factorial over m is a perfect square can be written as 2 to the a. is a perfect square. It can be written as 2 to the a, 3 to the b, 5 to the c, 7 to the d, 11 to the e, 13 to the f, where a, b, c, d, e, and f are positive integers. Find a plus b plus c plus d plus e plus f. For calculating this, you should know a lemma. The solutions are similar at the end that you want to find the sum. Okay? Because of sum, you should know sum of positive divisors, or we can say an idea. Look, you should know sum of positive divisors, product of positive divisors, number of positive divisors, and also sum of, for example, even positive divisors. All these things, a lot of things, multiples of 3. There are lots of ideas. I will tell you sum of positive divisors only because it's useful here. For example, if sum of positive divisors of, for example, 24. You say 24 is what? 2 cubed times 3. Okay? So, if you consider this, let me show you. 2 to the 0 plus 2 to the 1 plus 2 squared plus 2 cubed times 3 to the 0 plus 3 to the 1. Then all divisors will be created. For example, look, 2 to the 0 times 3 to the 0 is 1 plus other things. For example, 2 cubed times 3 to the 1, 24. So the idea is this. Okay, at the end for sum. Now let's focus on the problem. We have 13 factorial over m. It should be perfect square. So because it should be perfect square, we should do what on 13 factorial? Yes, we should prime factorize. You can use formulas, but we try to prefer to solve it without important formulas, only with ideas. 9, 10, 11, 12 over m. So let's consider the power of 2. Let me erase 12. So it is 2 to the what? Look, 2 to the 1, 4 has 2. 6 has 1, 8 has 3, 10 has 1, 12 has 2. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It is 2 to the 10. Now let's focus on power of 3. 3, here 1, 1, 2, and 12, 1. So it will be 3 to the power of 1, 2, 3, 4, 5. Times, the next one 5. 5 and 10. So it will be 5 squared. For 7, it's obvious because we have only one multiple of 7, 7 itself times 11. And the last one is, 13 factorial. So we should have 13 also here. Let me move it to right side. Okay, and so we have 13. 13 has no effect on 2, 3, 7. At the end, you should add 30. And now, because it should be perfect square, so here we have 2 to the power of something. For example, 2 to the power of x times 3 to the power of y times 5 to the power of z times 7 to the power of, for example, w, 11 to the power of r, 13 to the power of q. So we have these powers. Now, because it should be perfect square, if we calculate, it will be 2 to the 10 minus x times 3 to the 5 minus y, 7, 5 to the power of 2 minus z, 7 to the power of 1 minus w, 11 to the power of 1 minus r, 13 to the power of 1 minus q. All powers should be at least 0. And we can say, it says m. Look, it says m can be written like this, 2 to the a times this. So here, and this one, 13 factorial over m, like this. Okay, it is m. Okay, so we can do something. We can write it because the problem says a, b, c, d, e, f. So we can write it like this. A, B, C, D, E, F. So it will be 10 minus A, 5 minus B, 2 minus C, 1 minus D, 1 minus E, 1 minus F. So the powers here should be even. All powers are even because it is perfect square. Even and at least 0. Even, even. Even. Now, let's focus on A, B, C, D, E. Because 10 minus A is even, so A is also even. And A can be what? 0, 2. It should be at least 0, 10 minus A. So it can be 0, 2, 4, 6, 8, 10. B should be even. So B, 5 minus B should be even, so B is odd. And B can be 1, 3, 5. 2 minus C even. So C should be even. So C is 0, 2. 1 minus D should be even. So D should be odd, and the only possible case is 1. Okay, D should be odd, and the only possible case is 1. Similarly, E should be odd, 1. F should be odd, 1. And it says calculate all things like this. Because the power of 2, the sum of them, we should use exactly the thing in of the solution. I said sum of positive divisors equal to what? Here we should do the same thing. We say, okay, A is the power of 2. So, because we want to calculate sum, you say A can be 0 or 2 squared plus 2 to the 4 plus 2 to the 6 plus 2 to the 8 plus 2 to the 10. And for B power of 3, it can be only 1, 3 to the 1, 3 to the 3, 3 to the 5 times C is power of 5, 5 to the 0 plus 5 squared. For D is 7 to the 1, 11 to the 1, 13 to the 1. So sum of them is this. Let's see the problem says remainder or not. Find A plus B plus C plus sorry, it says calculate the sum. Sum can be written like this. So it is not A, B, C, D. A, B, 2 to the A, this is sum of all of them. So you can change it to this prime. A prime, B prime, C prime. It says the last answer can be written like 2 to the A. And this, so it will be this. Now, we should calculate this last answer, and we should write this as 2 to the A, 3 to the B, 5 to the C, 7 to the D, and 11, 13, 11 to the E, 13 to the F. And then find A plus B plus C plus D plus E plus F. So let's calculate the first one. Let me tell you a formula in general that you should memorize. If we have 1 plus R squared to R to the N. There are around 5 basic formulas. One of them is this. You should memorize them. If you want to know the others, I said before, feel free to send message to my WhatsApp number in the description and comments. So in this case, 2 to the 0 to 2 to the 10. We can say because it's 1, 4, 4 squared. Here, R is 4. Because look, it is 1 plus 4. The last one is 4 to the 5 or 2 to the 10. So N is 5. So here it will be 4 to the 6 minus 1 over 4 minus 1. If you use the formula. The next one, let me write below each case. Here we can calculate without formula because 3 is 3. It's 27. 3 to the 5 is 243. So it's 250 to 72, 73. Okay. Times the next one. The next one is 5 to the 0, 1 plus 25, which is 26. The next one is 7, the next one is 11, the next one is 13. Now let's simplify more. 4 to the 6 minus 1 is what? Is 2 to the 12. 2 to the 12 is 4096 minus 1, 4095 over 3. Times 273 is 9. Or we can simplify 3 times 91 times 26 is 2 times 13 times 7 times 11 times 13. Now, if we divide 4095 by 3, it will be 1, 3, 6, 5 times 3. We can write 91 as 7 times 13 times 2, 13, 7, 11, 13. So let's focus only on first number. We see that this number is it multiple of, it's multiple of 5 first. We can say 2 times 5, 10, 36, 7 times 5, 15, 3. And again, 273 like this is 3 times 91, 3 times 7 times 13. So it will be 5 times 3 times 7 times 13 times 3 times 7 times 13 times the rest. 2, 13, 7, 11, 13. And then the power of 2 here. It's 2 to the power of 1. We've finished this. Times 3, 3, 3, 1, 3, 2 3s. So 3 squared. Okay? Now let's consider on 5. 5 we have times 5 to the power of 1. Now let's check 7. 7, 7, 7. We have 7, 3, 7. So 7 cubed. The next one. 11. We have 1, 11. Okay. 11 to the power of 1 and 13. 1, 13, 2, 13, 3, 4. 13 to the power of 4. And we should calculate the powers here. Problem 5. So let's consider it is A, it is B, it is C. The problem says D, E, F. So we conclude sum of A plus B plus C plus D plus E plus F equal to 1 plus 2, 3, 3 plus 1, 4, 4 plus 3, 7, 7 plus 1, 8, 8 plus 4, 12.